Now it's working. There we go. It's probably going to be a shorter stream today. Because I'm late. Just a moment. Okay, post and Discord, post and other Discord post. There we go. Okay. Hello everybody. Hello, Shepley Ram? Shepley Ram? Every day? As in, am I gonna stream every day? Probably not. But I am kind of curious, like, just as an experiment, like, what would happen on YouTube if I do that? Because I've only ever tried streaming consistently on Twitch a long time ago, but I've never tried that on YouTube. So I'm kind of curious how that's gonna go. Conclude sheep for sure. Gotcha. Okay. Just watch my, or I went to my YouTube studio page and it was like my subscribers gained per day usually hovers around at like, what is it? It's like 20 or something, like what, wiggling a little bit up and down. The moment I started streaming, it went to the negative for like the first time. This is a long time. So I'm like, oh, okay, I guess people are unsubscribing now. I'm sorry for streaming. It's like, oh, people were reminded that I exist and they were like, ugh, hate this person. Why did I subscribe to this person? Okay. Theoretically, I also can't stay for too long today. Do not need to save that. Caught you in the middle of finishing your last VOD. Oh no, did it do the thing where like it takes you out of the VOD or something? Or it like interrupts your playback progress? I had issues with like YouTube VODs acting weird, but maybe it's like if I'm watching a stream, but I'm like way behind in the stream and then the stream ends and then YouTube for some reason doesn't remember where I was and I have to like figure out where I was for some reason. Like it's kind of annoying. I don't know if other people get that or if it's just a me thing. Oh god, I have way too many things open. Let me just organize my windows. Okay, I got that. YouTube should probably give users more options for what they get notifications for. Potentially, yeah. Like if people want notifications for high effort videos, and they get notifications for all of my streams, they might just unsubscribe instead of like disabling notifications. What is Half-Edge? Half-Edge is a 3D modeling tool that I'm making. So it's kind of like Blender, except not Blender, but it's a 3D modeling tool. That's what I'm making. Okay. I have this yogurt that I forgot to shake. Otherwise it gets stuck in the bottom and in the lid. Okay. Why can I not open this? How are the cats today? They are sleeping. It's like completely peaceful and quiet right now. I'm trying to sneak in a stream right when they're sleeping. Oh, excuse me. Do you have a stream schedule? Nope. I do not. That is... I don't have a stream schedule mostly for burnout reasons. I don't want to put too many expectations on myself. Because I have ruined my ability to deal with stress as a motivating force. Because I did that too much in my past, for the past few years. So unfortunately, things like a consistent schedule is kind of difficult to stick to. Okay. It's probably going to be a shorter stream because it is late. I'm going to try to see if we can implement the new Barycentric stuff that we did last time. So last stream kind of got cut short because my internet just completely cut out. It just dropped, and then I had no internet for, I don't even know how long. I went to bed like a couple hours after or something, and then I got internet back just in time to like keep me awake in bed, looking at a phone instead of like trying to sleep. Okay. Right. So, I've rotated the triangle since last time, so you missed that part. I also changed the styling a little bit, but the last thing we were doing on stream was to, well, actually, to zoom out a little bit. Let's just open half edge. Hopefully this works. Maybe I broke something somewhere, but hopefully it's fine. So this is half edge. This is my 3D modeling tool. It's a standalone modeling tool. It's not a Unity plugin. It kind of looks like it's in Unity, which it is, but it's because I'm making it in Unity, but it's not a Unity plugin, which is probably a little bit confusing, but once it's released, it's going to look less confusing because then it's just a standalone application. So the thing I've been working on lately is specifically the bevel operation. So beveling is one of those things that's like, it's a very tricky problem, and you can go super, super deep on this. And I'd been sort of holding off on doing bevels because I was sort of intimidated by them. But the past few days, I've been trying to actually get them done. And I'm making pretty good progress. It's definitely not finished, but right now I have a basic implementation that supports like specific cases. So right now, I support like the intersection of 3 edges on a vertex, so that works. And the thing I was kind of curious about last time was that I didn't like the way these points were distributed. I didn't like the way it looked. Like I'm pretty happy with the fact that, you know, I've managed to have quads throughout this whole thing, which we talked about it last stream where, you know, 3D artists tend to like working with quads for a variety of reasons, but one of them is for selection purposes, because you can have this, you can kind of select a quad strip, and then you have a very like neatly arranged pattern across your mesh. And so that's usually something known as edge flow. But of course there's some exceptions. So even in this tessellation, if I had like, what do I have here? Instead of 8, instead of a subdivision of 8, if I had a 7, there would be like a triangle in the middle. So it's kind of difficult to just have quads on their own, but I'm trying to do it as much as possible. So anyway, so I wasn't super happy with the way that the points were distributed on this. It's not exactly a sphere, but it's kind of like a sphere. Like the way these individual points are distributed, I don't like, because if you look at this very sharp turn, looks very ugly to me. And it kind of makes the surface look uneven, even though the points are on a smooth sphere, right? And so last time, I wanted to experiment with it, like if there's any other distributions of the vertices that would make this look a lot more natural and flowing. So like, for example, like I would want this vertex to be here rather, and kind of like ease into these a little bit more. Same thing with this one. Like if this was a distribution, I think that I would be happier with something like this. So I wanted to experiment with trying to figure out how to kind of optimize for certain variables within these coordinates on the bevel. And so that's what we did last stream. We kind of did it in isolation, so it's not implemented in Half-It itself yet, so this is kind of just it's kind of just living on its own over here. Actually, let's do perspective. So let's set step count to 0. So in this case, this is actually the same tessellation that we saw on the actual bevel in Half-Edge. And there's kind of different ways of like naively getting these coordinates. So also the colors right now, that it's colored by deviation from an ideal. So any square that's red has slightly too big of an area compared to the average, and anything that's blue has too small of an area compared to the average. And so I wanted to try to make an algorithm that would optimize for equal area. Like as much as possible, I wanted this geometry to try to make equal area cells in this. So we were working on doing a solver for that last time. Kind of like a force-based solver. I think people said that this has a name. Was it a Jacobi style solver? I don't actually know what that is. I just remember something like that. I vaguely recall doing something similar for like fluid simulation. Anyway, basically the idea is that we iterate through every single face, and we check the discrepancy between the current area and the ideal average area, and then we add a force to the vertices, kind of pushing them outwards or shrinking them inwards. And then we add all of those forces up on each vertex and then multiply that by some number to just add some friction. And then the simulation hopefully creates a better distribution of these vertices. So I don't actually know if this is going to work immediately. But yeah, so we're going to start experimenting with this kind of stuff. This is actually really pretty. I didn't see this pattern before. But yeah, so as you can see, like this one is now optimizing for area. And as the colors go away, that means that it is very close to optimal. Because that means that every face is as close to the average area as much as possible. But obviously we can't just optimize for area, because this tessellation has like really skew like cells. Like this is not even convex. This one is concave. And we really don't want concave quads. So then we had some other heuristics. So for example, we wanted to do a heuristic on optimizing for internal angles. And that's what you're seeing here with the pies. So the pies are basically showing the discrepancy from the ideal angle. And the ideal angle is usually 90 degrees. So the optimization is going to try to make all of these corners 90-degree corners. And so the way that this works is that we can kind of independently increase the priority of, you know, weighting by area or weighting by angle. So if I increase the angle optimization, you can see that it immediately fixes the like super jagged angles, right? So it immediately starts optimizing for internal angles. But it is unfortunately kind of fighting with area now though, because it's a bit of a trade-off. If you fix the angles to be a lot more orthogonal at every intersection, then generally you will also change the area of all of these triangles. And so you can kind of see the colors coming back in because now they deviate from the ideal area more now. And so, yeah. And then the thing where the stream got cut because my internet just disappeared was that we were going to add an edge length optimizer as well. And the edge length optimization is kind of like it's optimizing to try and make each edge the same length in each face. So it's kind of taking the perimeter of every cell and then trying to make every edge, that perimeter divided by the number of edges. Basically trying to make everything have side lengths of the same length. And I was just about to implement that, and then the stream disappeared yesterday because internet disappeared. But I have that implemented now. So now we have an additional slider to optimize for edge length. And I find this one really interesting because this looks like a perspective projection. Like it looks like a 3D corner of a room or something, which is really unexpected. I really didn't expect it to do that, but there's probably some good reason for it. But so I dropped the area optimization and I dropped the angle optimization. Can sort of see what it's trying to converge to. This one is kind of it's trying to converge to like almost straight lines connecting here, but then of course it has to bend because the center isn't the same number of steps away. But yeah, I found this super interesting. Of course, there's some combinations that kind of blow up because it's not a super stable simulation. Yeah, so that's kind of what it is. Wait, where's the step count? There we go. This is so satisfying. I love seeing this just optimize around. Would relax be applicable as its own relax tool, or is it specific to this bevel structure? Well, secretly, I will also wanted to experiment with this because I'm going to need to do stuff like this when I do UV mapping. Because I loved like UV mapping in Maya because it had the interactive unfold. Because then you basically get to see a solver work with your UVs, and that was so satisfying. So I'm going to do something similar for UV mapping down the line. There might be some similar optimization stuff for like the actual 3D coordinates of a mesh as well. Like, I don't know, if you do something like you have a bunch of quads, but they're a little bit noisy or uneven, then you could maybe make some kind of relaxation algorithm to try and smooth them out. But primarily, this is something I'm mostly going to be using for 2D stuff. But yeah, so I kind of like the way that, oh, it explodes. Oh, don't explode. So I'm trying to figure out what I even want for the optimal solution here. It's probably pretty case dependent, but I feel like a lot of these are really good. I think like almost all of these, like regardless of the actual combinations I have of these weights, they're all looking really, really good, unless I explode it, of course. It's mostly a matter of like how much do I care about the area being smaller in the middle, and how much do I care about this sharp turn. I think I kind of care quite a lot about these sharp turns. So like, I don't think I would want something that's like this. Actually, this one does have less sharp turns, but I think this one looks a little too extreme. Yeah, I think I would want some kind of mix between these. Yeah, I really like it when this looks like a smooth arc. Obviously, it has to be sharp in the middle, but having these look continuous, I think is really nice. Yeah. Yeah, I'm not sure if I like the edge optimization. I might end up not using that. Yeah, I think both area and angle are really good together. I don't know. I have not tried to visualize this on the actual bevel yet. No. So all of this is right now. This is purely in barycentric coordinates. They're not on the actual surface. So I'm hoping this is going to be looking good in pretty much all cases. But it's hard to tell. It's hard to tell ahead of time. Could you compute the areas, angles, lengths after the points are transformed by the Bezier surface to account for distortion? I'm hoping I don't have to do that. Yeah, because if I can get away with this, I don't need to like compute this for every single bevel. It would be kind of nice if I can just have this be computed once for every number of corners, right? What's the performance for the solver? Doesn't really matter. It's somewhat slow. I don't know. I mean, let's see. When does it explode? Okay, it doesn't explode here. So this one converges after around 28 iterations, which is not very long. And the thing is, like, I only need to calculate this once for every number of subdivisions. So, I mean, I could just cache this. I could just store all these coordinates in an array and then use that. So I can compute this whole thing offline, but I mean, it's fast enough to compute it real time. And then just store it in memory, probably. Feels rude that you made this so visually pleasing and interactive. Rude? What's the what's the rude part? Does the number of subdivisions affect the look of the optimization? We can test. Not really for the area. It looks kind of consistent. I think this looks pretty good. I'm down for this one. I appreciate the way this looks. This looks very soft to me and continuous. Like as much as you can get for a weird shape like this. Oh wait, this looks kind of weird though. Hold on. The way this line kind of has an indent here looks kind of strange. I wonder if I can increase the solver count. Okay, it doesn't really fix that. Is it the... no, okay. Oh, if I loosen the angle constraint, then... okay, so maybe I want to adjust it just so that this one doesn't have the you know, turning left and then turning right. Okay. I think it's mostly consistent now. It's easy enough to change these things later, I suppose. Especially if I just, like, just compute it rather than, like, storing them or whatever. It'd be interesting to see if you can come up with some sort of direct algorithm for constructing these. That would be cool. I tried doing that and then I failed, and so I figured I would write a solver because I'm gonna need that for UV mapping later anyway. But it does kind of feel like, I don't know, like looking at the shapes here, it kind of looks like these, like a hyperbolic path around like a central orbit type of thing. Yeah, it's kind of neat. Why optimize for area and edge length instead of tracing geodesic paths? Like, do you mean tracing for when the bevel, like the way that the bevel is connecting, or, because I mean the geodesic is gonna create weird situations, right? Like if you consider the geodesic from this point to this point, it's gonna go across the wrong side of the center, right? So I can't use a geodesic here. Unless you mean using it in a different way, but okay. I think edge length was a good, oh. This looks so neat. Does anyone want a print of this? I really appreciate this. It's like a weird, like, kaleidoscope thing. As soon as it breaks. I could make a music video from this. Neat. You need special broken presets? You know, anytime I post like a broken bevel when I had like shuriken shapes, people were like, oh, I want to try to make that work. And I'm like, are you aware of just how broken this topology is? It is very broken. God, I love how like iterative solvers, they feel so alive in a way, because it's just, well, I guess it's just because it's simulating. But I really appreciate the way that they behave. Because it's so, like, I don't know, unexpected I guess I'm just not used to writing simulations, but it's very satisfying seeing this solve. Oh wait, I forgot what parameters I was using. I'm just playing with this now. Let's see. I want to use as few solve step counts as possible, but still converging. And I wanted this inner one to not be wobbly. And it showed up here especially. Yeah, like this like going right, left, right is not good. This is the type of thing that I want to avoid. Guess here somewhere I feel like it's doing pretty well. And it's converging after like not a whole lot of iterations. Like 20 iterations is perfectly fine. So this is 10 iterations. Yeah, even 10. There's like barely any movement after 10. Which is good for generating this, I suppose. I think the way I'm going to do it is like when you bevel with like a subdivision count of, what is this, 7? Then I'm going to generate this real time once for 7, and then it's just going to be stored in memory. So anytime you do another bevel, it's just going to use that one. I think that's the way I want to do it. Although it's a little bit tricky with the way that I've set it up right now, I think, because I'm kind of hijacking my mesh data structures for this, which is not the best, but maybe that's okay. Difference of bordering angles, another criterion. What do you mean? Maybe it could be scaled hyperbolics going from one infinite parameter to another. Yeah. Yeah, one thing that I was thinking of is like, if you consider this line right here, let's just increase the tessellation. Like this line along this edge, and then as you go one step further in, like every new transition is going to be more and more sharply turning towards the center. I feel like the limit to this function kind of stops here. Because I think like continuing that pattern here, I don't think that's part of the same like hyperbolic like structure. Because I think that's kind of like a side effect of the other curves just crossing each other. So I would guess that if I were to like try to make like an analytical version of this, I'm guessing it would just be based off of the like hyperbolic curves up until the middle point, and then the middle one would be the limit. To get a smooth transition? But like difference of bordering angles with what? Like geometry outside of this, or? Because right now I want to try to make this independent of the surrounding geometry. I just want to have better barycentric coordinates. And if that looks good enough, I'm gonna be happy, because then I don't have to do like very expensive optimization stuff. That's gonna be like on a per bevel basis. Like I would prefer to not have to do that. That would be nice, because then that's gonna be much more performant. Because then the idea now is that I'm going to take these coordinates and then basically just use these barycentric coordinates in the triangular bezier, and then that's it. So that way I don't have to like care about any neighboring geometry or anything like that. But then the question is, do I implement this in the bevel immediately, or do I visualize this on a triangular bezier first. I think it's going to be easier to iterate an experiment if I visualize it on a bezier patch. So I think maybe we'll do that. Which actually shouldn't be that much work. Okay, I have so many things here. Okay, I'm just gonna close everything except this one. So how did I do it for the beveler? Did I end up with code that just required the normals? Or did I need the edge directions as well? Because I do pass the directions into this. Oh, I do use them. For what, actually? D0. Okay, right. Okay, we can just hard code this, I think. So cubic bezier triangle. Is minimizing edge lengths out of the question? Oh, minimizing edge lengths. I guess I haven't tried that. But I really don't want to minimize area though. Because I want the density of the mesh to be relatively consistent. And I think that would probably shrink quite a lot, but then the question is like, how would that interact with the area optimization? If you try to minimize edge lengths and optimize for area, it might reshape them in ways that's interesting and useful, but I'm not 100% sure. Okay. Wait, do I have a quadrangulated triangle? Oh yeah, because I'm using for the tessellation stuff. Okay. I guess we have a bezier, and then now we need our corners. What do I pass in here? I guess we can just do... hard coding stuff like this when there's so many parameters is kind of annoying. Okay, I'm just gonna do this. Okay, so we're gonna place them at, let's see, X. What order is that? X, Y, Z. That's left-handed. Good. So X, Y, Z. Face normal. So face normal would be also X, Y, Z, I think. And then corner direction would be Z, X, Y, I think. Okay, I'm probably gonna have to switch this later, but because this is a bit of a guess, but it's not. It's not X, Y, Z, or it could actually be. I forget how I order all of these things. Okay, how did I draw this last time? Didn't I make like a generalized function for this to draw? To draw? Where's debug bezier triangle? That's the one. That's the wrong code. Okay. I guess I don't want to rotate anymore. Or do I? I don't know. No, I don't want to rotate anymore. Because we're going to do this in the triangle. So let's just debug this first. And we do want to fill these. Okay. Let's do just those for now. Oh yeah, I'm getting this bevel raycast failed thing. Okay, well, that probably means we got the order wrong here at the very least, so I guess we'll just try all the permutations until it works. Because I'm pretty sure the 90-degree angle case was working just fine, so... I'm guessing one of those, they were just like... tangent. Wait, is it really XYZ? Huh. Huh. Fascinating. Why is this? You're making so many clicking sound when you're not doing anything? Yeah, I'm very inefficient with my keyboard use. Like, I will hit Control S like multiple times, or like tab back and forth and like just spaz out entirely, because I don't know. I'm not optimizing. I'm not optimizing my number of inputs. Yeah, this should be just a simple, like, corner cap of a circle, but somehow this is failing. But, like, what corner point am I even passing into this one? Yeah, there's something broken with this code. Okay, so how did I pass this in last time? So this is in the beveler. Okay, this is in the order of the corners. I think it might actually be reversed in that. Okay, I'm just gonna try. Oh wait, I would have to reverse all of them, right? I think. Why do I keep getting this issue? Okay, spline punch, and it is this one. This really shouldn't be a problem. Where's my other bezier patch? This one's working fine. What did I do different? Why is this one fine? This one's like the exact same case, except it's wonky. It's not aligned. Wait, that's not the script. This is the one. Okay, this one is just manual. Right, because I'm not doing the... I'm not calculating the patch. This is just purely from... directly from positions that I manually set. Okay, well, you know what? Let's just use this one. We're gonna use this one, because this one already works. So we're gonna make a reference to my other debug thing, not that one. Yeah, this one, except Unity doesn't like it when I undo. Okay, how do I do this? I would need to public what did we call it? Barycentric relax test. This is not showing up. Did I mess up the assemblies? I probably did. Berry relax. Gotta relax, Berry. Yeah, it's in a separate assembly, that's why. Okay. So I will move it into here, I guess. There we go. Okay. So now we should be able to reference that. Can I access the what do I want actually? Is it tetra to point? Or no, I guess I can just make a function to iterate through the barycentric coordinates. Yeah, that's what I'm gonna do. Okay, so put public, public, I enumerable, int, no, float, 3. No, wait, because I want to be able to draw pretty graphs, so that's not going to work. Okay. Maybe I should just reference this the other way around, actually. So where's our, that's the name of that one. Okay, we're gonna swap this. There we go. Gonna comment that out to not confuse myself. And then we reference that. And then in here, we should now have access to the I guess all of these are drawing based off of the 2D coordinates. Right, tetra to vertex. Oh, it's actually using the vertices. That is interesting. Okay. Am I using that for drawing as well? So, where's my draw function? Draw shapes. So where do I draw lines? I do use the vertex positions. That's good because these are 3D. So then I could just modify the mesh to fit the whole thing. So maybe I will make that a checkbox. Public bool fit to cubic bezier. What? I can spell. See, I'm not efficient at typing. It just sounds like I'm typing a lot, but it's just mostly useless keystrokes. Okay, so calculate forces, and then recalc mesh. I guess I can do the moving of the vertices here. So this is where we would take all the vertices from barycentric coordinates to let's see. Yeah, because they're not actually barycentric coordinates because they're 2D. But I can just convert them from 2D to barycentric to a point in the Bezier patch. I think that's the way to do it. So if we want to fit it to the cubic Bezier, we have a final step of iterating through all the vertices and moving them to that patch. So I guess we iterate through tetra to vertex. I think? No. We want the vertex to point, maybe. Yeah. Yeah, because that contains the calculated coordinate. Okay. So those are bad variable names. This is vertex ID. And then we have the, I guess, point. So then we want to do mesh, no, that's going to be the last one, but mesh dot set vertex position, vertex ID, and then we need the actual coordinate here. So that would be because like world position, I suppose. That's going to be the thing we're going to calculate. But we're starting out with the position here, which is a 2D position. So this is like flat barycentric. And then I believe I have a matrix. I think it's in barycentric. Barycentric dot, yeah, okay, so I want to go from flat coordinates to barycentric coordinates. So I multiply that. So that should give us the actual barycentric coordinates. Okay, Unity, what now? What operator did you not overload? Is this not valid? Hold on. Float 3 by 4. Oh, wait, does it have a, have to be a float 4 maybe? Wait, so it'd be like 0 and 1? Still? Am I stupid? Oh wait, do I need to use math.mul? Is that it? Oh my god. Unity, your math library is a little bit annoying sometimes. Overload the operators. Just overload the operators. Then they're gonna say, but it's ambiguous, whether it's a row or a column vector. And then I'm just gonna say, well, do it the same way shaders do it. Okay, flat to barycentric. This gives us a float 3. Yeah, and then we use the spline. How do we get the spline? That's referenced, right? Yeah, okay. And do we actually have access to the spline? No. Right. So we're gonna make a public field for that. And I guess I just want to make sure it's not null, but I guess I can null check. That's fine. What did I call it? The Bezier triangle test? Bezier triangle test. Bez. Okay. And then I guess we just do .bez.eval, and then we pass the barycentric coordinate directly in there, and then we have our world position. Wow. And then maybe recalculate the mesh. I don't even know if we have to do that, but I guess it would. I guess I would need to do that to get the proper normal directions, but I'm not actually rendering it as a mesh. I'm just hijacking my mesh system to draw separately for my debug info. So I don't think I actually need to do like proper recalc stuff. Okay, so for this to work, this one has to be at 0 because we're kind of making assumptions about space. And that should be it. Let's try it out. See if it works. I hate blue switches. These are actually blue switches, but it's a low profile mechanical keyboard, so it's this one. Come on, camera. Come on. Come on. Come on. No? Okay, the camera is just refusing to. Well, this is a keyboard, believe it or not. And it's got kind of flat keys. But it's mechanical. I guess I can like hold it next to my face because it wants to like focus my face. So it's flat mechanical. They're called Cherry ULP. Yeah, Cherry ULP, ultra low profile, I think. Cherry ULP blue switches. And they're less loud than like big, actual chonky blue switches. So, I really like this keyboard. I really like laptop keyboards, like the Mac keyboards are really nice. So I wanted something similar for Windows, and this was a really nice. This was really nice. Good keyboard. Right. I should remove the code that keeps throwing exceptions. Where did that happen? Yeah, well, not that far back in the... Oh, sorry. Oh yeah, this is the thing that was failing. Wait, what? What? Oh. I'm stupid. That's why. Okay. Let's see if it works. It is not working. Wait, what? Why is this? Or is this from a previous run? Oh, okay, it's just doing nothing. Okay. Okay. Am I casting them to like 2D or something? So let's see, how do I draw these? And yeah, it's this one that's drawing it, I'm pretty sure. Wait, let me just... Okay, yeah, so it's still working at least, so it's not like old data or something. So then... What is going wrong here? I mean, it's making a new one every draw, so it should... This really shouldn't be null, so it can't be that. And I'm using it to draw elsewhere. So what could be going wrong here? I guess maybe my matrix transformation is potentially... But I'm kind of confused as for why it's drawing as if it's not transformed at all. Because I feel like it should be using the mesh coordinates, right? Okay, let me see. Draw shapes. Internal angles. So this is getting vertex positions directly. So this is the mesh data. Am I maybe using... No, I'm using billboard lines. Okay. I am fascinated by this now. How is this not setting the vertex positions? Don't tell me I just forgot to recompile. It's gotta be something more interesting than that. Okay, I'm just kind of baffled now. I guess I'll just comment out drawing code to see if I'm actually... Am I even looking at the right drawing code? Because now I'm wondering if the problem is me. Oh, wait. Recalc mesh actually sets the vertex positions. That's the problem. Cool. Cool. That is my bad. Maybe I can just not call that. I think it's gonna be okay. I am not doing Arduino code, no. That works. That just immediately worked. I guess the area and the angle pies are kind of making assumptions now. I think it's doing the 2D area calculation for these, so that's why the colors are very off. I guess we should just clean those up, I think. Which is not too difficult. Okay. Let's see. We got our... These are the internal angle ones. Okay, maybe I'll just not draw the debug stuff on the 3D thing. It would be cool, though. It would be really interesting to just have those still work. Do I fix them to work in 3D? Although they're not going to be based off of the 2D stuff anymore unless I make sure that they're doing it in the right order. I'm just gonna make them not draw in 3D. I do kind of want to see it working though. Okay, but for now I'm just gonna comment it out if we're doing the bezier fit. So that would be the internal angles. And the lines we're still gonna draw. Force vectors. I didn't even know we still drew those. I think they're always 0. So vertices we still want to draw. And then areas are going to be conditional as well. Okay. Cool. Look at that. Do I have too many dots here maybe? I guess I... Do I keep the dots? They're a little bit distracting. I'm just gonna make that a slider so we can adjust on the fly. Yeah, there are good references for like seeing the smooth shape. Okay, it's a little annoying that it's not smart about updating the thing. Okay. So now, yeah, dots. Zoom. This looks neat. Look at that. This is like the whole reason I like doing graphics programming, because like I get to just turn around a camera every now and then and be like, ooh, look how pretty this is. It's really nice to like play with graphics. What was I doing? Oh yeah, I wanted to see how the different weights and the strategies work on an actual curved surface. Okay, the dots are a little bit distracting, but no, they also communicate shape really well. Okay, I'm gonna leave them in for now. Okay. Hell yeah, we got our dynamic visualization here. They are... I do kind of want to make them a little bit darker. Can I set the opacity of them without setting the opacity of everything here? Probably not. I'm gonna just lower the opacity in general. See if it sticks. Hopefully, maybe. Come on, dots. Fade. Fade away. God damn it. Okay, I'm probably overriding the color. That's probably why. Yeah, I'm just overriding the color. Rude. Rude. Float. Dot opacity. 1. Boilerplate stuff. Okay, dot opacity. There we go. Now we have an opacity thing, and then we have the dots. And then dot width alpha dot opacity. There we go. Okay. Cool. We now have dot transparency. Advanced techniques in 3D graphics to have an opacity slider. They won't tell you about that in school, but real developers have opacity sliders. Oh, it's really useful to look at this on a 3D mesh actually, or like in a 3D shape. Okay, so what does it look like if I optimize by edges? Right. Yeah, this one pinches so much. I really don't like the way that it makes the tiny cells in the middle. It looks so pinched together. Don't like this. Don't like this at all. And then you kind of lose a lot of detail, where like you want a slightly better like tessellation. Okay, so if I then optimize by area, it'll expand a little bit, but now we have the wobblies here, which we don't want. So we want to optimize by angle. Probably not this much. This looks a little angry. Yeah, 'cause it's kind of smoothing out these right here, because this is a pretty sharp transition, and I really like it when that's smoother. Yeah, I think I want to drop the edge optimization. I don't think the edge optimization gives me huge amounts of benefits, so I'm probably going to set that to 0. I don't like how this one still looks a little wobbly. Like, it kind of looks like it's going straight, and then all of a sudden it's like... Or no, it's not too bad, actually. It's just as soon as it starts bending, it's a little wonky. It's kind of done bending here, I feel like. The outer edge looks kind of weird with edge optimization. It kind of like cancels out the curvature. Like it tries to make it straight or something. And here I feel like it's going straight and then it's turning left and then it's doing a sharp turn to the right. But if I remove the edge optimization, it feels better like this, I think. Okay. Uniform distribution, please. Well, ideally, but that's not possible. So the whole thing we're trying to do is like figuring out what things would we like to be uniform and what continuity do we care about, right? Okay, there was one case that looked kind of weird that had the wobblies. It was this one, yeah. This one had a bit of an extreme case here, which actually seemed to be kind of the worst case. Maybe this one would also have the same problem. Yeah, this might be actually... No, this one seems more fine. Yeah, this one looks weird here, because it kind of has this consistent curvature thing, but then here it turns left, right, left, right. Don't like this. That does push the angle optimization pretty far, and it shrinks the center quite a lot. I'm not a huge fan of that. Is this just an iteration count thing, maybe, actually? No. Oh, goddammit, I pressed undo. I pressed undo. Ugh. No. I don't even know what the best way is to fix this. I guess I'll press play and then leave play mode. Ugh. Okay. It's currently about how the points are positioned on the corner, right? How is the area determined? The area is calculated in the barycentric coordinates, or rather in 2D coordinates. So before this is turned into like a spherical section. But I'm not entirely sure what you're asking. Yeah, all of these kind of have the same issue. Oh yeah, wait, actually. Should the triangle be the same size as the quads? This feels like a moral question. Should it be half? Should it be 3/4? Yeah, because I feel like the triangle should match the triangle should try to match the edge lengths of its neighbors. So whatever area that turns out to be. Oh, I think there's a mathematical way to solve this, right? There's like okay. So if we have a square, actually we don't even need that, but let's say we have a square and this one has an area of 1, and then we have an equilateral triangle. Which I guess is just an equilateral triangle with edge length 1. What is the area of this triangle? I guess that's it, right? That's whatever that area is, that's how much smaller that area should be in a kind of ideal sense, right? Oh yeah, and because it's kind of like invariant, you can kind of like just move this vertex there. And then you're basically gonna get, what is the altitude of this? Is it like square root of 2 or something? I forget the altitude. 3/4? Is that the area? Square root of 3 over 4. Square root of 3 over 2. We have multiple different different answers here. Okay, well, okay, let's think for a bit. So we know that this is 0.5, and this is unknown right now, I guess. And yeah, we know that this one is 1. So it would be, that's a bad name for that. I should call it x. So x squared plus 0.5 squared equals 1. Wait, square root of all of that. Wait. Do I have to do the square root? Wait, because like, isn't it 1 squared? And then that kind of, that's just 1 squared. I feel like I shouldn't have to do the square root. But then is it even going to be the correct answer? Oh yeah, because I have to do the square root for this one. Never mind. Okay, I'm dumb. Okay, 0.5 squared, I believe, is 0.25. So then it would be 0.75, I suppose. Wait, is this square root of 0.75? The side length there? Oh god, my selection box is wonky. Photoshop. Oh my god, fix your input issues. Square root of 3 over 4. Oh, square root of 3 over 2. Right. Okay. So it's that times yeah, x times 1 over 2. Okay. So I guess the area is then it's just this over 2. Is that it? And that probably simplifies into one of the things you've all have written. I'm really bad at the rules for square roots. So this is 3/4. And if I divide this by 2, can I like manipulate the inner here instead? How does that work? Oh, square root of 3 over 4. Wait, but then I also have the division by 2, so it's square root of 3 over 4. Square root of 3 over 16. There's so many different ones. Okay. Well, okay, so square root of 3 over 4. Okay, I'm just gonna do this the way that I usually do. See, I'm not super good at math, and so my strategy is usually either Desmos or Wolfram Alpha. Okay, square root of 3 over 4. So this would be the area. Okay, wait, so would it be equivalent to do the over 16 thing? Yes, that is equivalent. Okay. What's the other one? We had square root of 3 over 4, and then all of this over 2. Yeah, they're all the same. Okay. Cool. Neat. Isn't it neat how math works? Wow, all of these, they're doing the same. Isn't it square root of 3 over 4 instead? Or wait, is I mean that's what I did here, right? Square root of 3 over 4 over 2. And then that gives the same as both of these. I think I'm on the right track. I think I'm on the right track. I'm gonna trust this. So no gaslighting here. Okay, so yeah, we basically need to add that into the solver then, that which one of these is nicest? I guess square root of 3 over 4 is probably nicest, because square root of 3 is a constant that I already have. So let's see. Okay, this file is a little long right now. Or rather this one. I should probably break it up at some point. Okay, where's the actual optimization? The optimization is in the same file as the drawing itself. Solve. Here we go. Calculate forces. Okay, area ideal. Cool. So this has to be different now. So basically we have the weight for the area for triangles is going to be the thing. So that's like math dot square root of 3 over 2. Wait. No. Over 4. What number is that actually? Oh, it's a little under half. Oh yeah, that makes sense. That makes sense. Okay, yeah. Because the area of this one is the same as the area of this one, this triangle right here. And we know that this one is less than 1. And therefore, there's a discrepancy here. So then that means that this triangle should have an area that's less than 0.5, because this half would be 0.5. But yeah, there you go. That was my super genius insight that I wanted to share with y'all. The super basic geometric intuitions. Okay, square root of 3 over 4 is the weight for that, and then the weight for. Okay, I'm gonna add a weight for the quads as well, even though it's just 1, because it will make my math brain a little happier. I guess I can make it an integer just to make the compiler happier. Okay. So, I guess all we need to do is we need to get 2 different ideal areas. One ideal area for quads and one ideal area for triangles. So we just need 2 different ones of these. Okay, so I'm guessing it would be something like it's basically if it's an, is it odd or even that has the triangles? It's odd, right? 1, 2, 3, 4, 5. Yeah, odd. So if it's odd, no, if even, then it's just quads. Then we just do the same thing we did before. But if it's odd, then there's 1 triangle. And so, oh, this is like a weighted sum type of thing. I guess it would be quad count times the weight of the quads plus triangle count times the weight of the triangles. But then I would have to normalize this. I think. Oh god, I feel like I'm too tired for this. I don't even think this is hard. Oh yeah, I need to get what is the amount of area that we dedicate to quads in total. That's the thing I want. And then I divide by the number of quads, right? Yeah. But okay, so it would be like float ideal quad area is area all quads divided by quad count, right? And then we have the ideal triangle area, which is or wait, what do I mean by area all quads? Oh yeah, the area allocated for all quads, I guess. In terms of a ratio. It's like a weighted ratio based off of the... Oh yeah, wait. Wouldn't I just divide to get this ratio? Or something? Because that would give me the proportion of the area that's allocated for one of the specific types, I think. I'm so bad with ratios. Wait, is this actually normalized though? Don't I need the... No, because it's just a ratio, so I don't need the actual area. That doesn't matter. So would this just be the ratio for like quad area proportion or something? So yeah, this makes sense to me. Okay, so this is the proportion among all this is the percentage of the surface area that's allocated for quads. And then I just multiply that by the total area and divide it by quad count. Then I get the ideal triangle area. Or no, quad area. Yeah. Yeah. Okay, this is not correct. So that one I need to fix. But yeah, this makes sense to me. So let's actually make this if statement. I guess we can just put these outside. Okay, if qt dot is even, I think, then we have the ideal, and then I guess we just assign the ideal to both of them. Maybe. Yeah. I mean, it's just going to be quads anyway, if it's even. So triangle doesn't super matter here. But I guess just in case I use this for other shapes, and I don't know. Okay, so then if it's odd, we have the quad area proportion. So quad count is, let's just do a face count. Face count is all of this. So quad count is simply face count minus 1, I suppose. And then triangle count is just always 1. It's never ever anything except that. Because there's only ever one triangle. But let's make a try count just to make it a little bit more comfy. Oh, you know what? Hold on. We're gonna make this even more generalized. Look at this. We're gonna subtract the try count from the face count to get the quad count. We're not gonna make assumptions here. There you go. Defensive programming. Oh yeah, QD is the quadrangulated triangle, yeah. Okay. This part of code should activate only for odd subdivisions to save compute time. That is what this if statement is for, so it is already doing that. Okay. So this gives us the proportion, and then we want the ideal quad area. Oh my god, I have some shortcuts way too close to return. Wait, Oh, yeah, barycentric.area is the total. So that's just quad area proportion times barycentric area, I guess. And then, or no, wait. This is the total quad area. And then we need to divide that by quad count. I feel like this whole thing probably simplifies to a simpler equation because we have quad count in here as well. So like quad count would probably cancel out or something. And then, I don't know. But this makes sense in my brain, so I'm gonna keep it like this. Okay, and then the ideal triangle area. So ideal triangle area would be, it would be 1 minus quad area proportion times barycentric area divided by triangle count. Wouldn't it be something like this? Ideal quad area equals total area divided by quad count plus triangle count times relative size of triangle to quad. Maybe? Oh yeah, the even. I haven't actually set the... Sorry. Thank you. Okay. Okay. Just kind of triangles as fractional quads. But I feel that there's got to be some kind of like normalization factor there though, right? Or maybe it's already normalized? I'm really bad with ratios and proportions. Okay. No, wait. Edge count. So this would be mesh dot get count, half edges in face, face ID. Right, okay. Float area ideal equals edge count equals, or you know what? You know what? What if we do some more defensive programming here? Look at that. So if it is 3, we do ideal triangle area. If it's 4, we do ideal quad area. Otherwise, we throw an exception. Oh my god. Then it's gonna like communicate something to us. Not implement an exception. Are you gonna do the same for polygons? I don't think I need to. I don't think there's any reason to do that. Because I want the bevel to always create triangles and quads anyway, so I'm not gonna make n-gons. Okay. I think that's it, right? And then watch as it makes 0 difference. Or maybe it just fixes everything. It's just gonna make it, all of a sudden, this case is just gonna magically pop into place. Although it's gonna become 2D first, because I wrote bad code. Oh. Index out of bounds? What? Hold on. Excuse me? Oh man, the solver is really upset. Oh wait. Or, hold on. Did I mess this up? Head count, 3, 4. That's a float. That's a float. Wait, is this even or odd? We are on an odd one. Does it work if it's even? Yes. Okay. So we're specifically having an odd problem. I am getting an index out of range here, which means the intersection test is failing. Oh yeah, okay, so something is completely out of whack. Okay, is my triangle area completely off? Did I miss something? I'm guessing I must have made something wrong there. Like this. Bevels only do this when they're very distressed? Yeah. It's not good. Oh wait, should this be... No, it should be 1 minus, right? Or should it be 1 divided by? Hold on. Or am I stupid? Am I being stupid again? Because it's got to be that this one is completely off. Okay, what if I just make this one the same as the quad area? Pretty sure it has to be 1 minus proportion. Yeah, I feel like it should be. It's kind of going haywire here too. Yeah, the ratio quad area to triangle area, but I think I want the ratio to be quad area to total area. That... Well... Isn't that the same thing? Or wait, no, hold on. I think you might be right. Is it like I want this to be there as well, because this is the total, because I want the total area, or like total proportion, or the proportion of quad stuff compared to all the stuff. Yeah, this would be correct, I think. Yeah, this makes sense to me. Oh yeah, because the ratio quads to triangles would be a very large number, like larger than 1. That is very satisfying. This makes sense to me. And we are optimizing for area, so that's good. Neat. Hell yeah. Hell yeah. Okay, did we solve the problem of the weird wobblies at these? I guess this was the case that kind of looked pretty bad without a very high angle threshold, but now it looks like I can actually keep it lower. Yeah, that's good. That slider does nothing. Ooh, it's feels a little shaky here. Or is it just because it's doing big steps, maybe? It's a little scary to use a big force multiplier here. It kind of stops after like 24 iterations, at least with the current angle setting. This looks pretty good. Oh wait, this looks a little bit like a weird kink. But it kind of has to. Like, I guess if I go up another one. Like, the closer you get to the center, there has to be a pretty sharp turn here in order to preserve the areas in the center. So it's probably kind of inevitable. Yeah, because if I want to, like, flatten that, I'm also going to shrink the center. So that's kind of a trade-off between how much do I care about the area in the middle versus continuity of the edges. And like in the middle, there's always going to be a sharp turn. Like there's no way around that. So I think that's a case of like there's no optimal solution there. It's probably better to like optimize for the overall look, I think, in this case. To have like sort of evenly distributed quads. Yeah, how straight do we want this to be? Oh yeah, this one it is kind of interesting that like optimizing for edge length actually makes the tangent direction better. Which was kind of hard to tell on the triangle, but it's very easy to see here. That's the wrong button. Isn't continuity more important for the final look? I'm not sure. I mean, more important than what? The tangency, or... Because that's kind of part of continuity. Because if you imagine like edges going straight down here, like a connecting bevel, if it looks like this, like a straight line going from the bottom is going to sharply turn left all of a sudden. And is that bad? It might be. It's probably going to look a little bit weird. And it kind of looks like the edge length optimizer handles that pretty well. That's interesting though. Because this wasn't very visible in the triangle. Okay, so if we have edge optimization, how do we want to deal with the other ones? Okay, so this is a pure edge. Now it's purely edge-based. I'm not a huge fan of the shrinking quads. Because, like, theoretically, it needs the same density everywhere. And it looks weird when it's smaller in the middle. I just really don't like that. I really want to optimize for area as well. But that, of course, has some other side effects, but I think it's worth it. Be curious if it would make a difference which distribution looks most optimal depending on the shading mode. Yeah, I haven't looked at that. Wait, the middle could be a pentagon? Like an n-gon? Okay, you know what? I wasn't too fond of the edge length optimizer, but now that I'm looking at it, I think edge length optimization is good, actually. Please don't explode. Do you like this bevel? Every time someone in chat says, you should turn that into a slider and expose it to users. Do we want to expose users to this? I'm gonna get sued in court because people are gonna get hurt by all of this, mentally and physically. I can't expose dangerous sliders like this. I'm gonna be liable. This does not look healthy. This is like a workplace safety violation. Jesus. Okay, good. I was like, wait, does the default one actually look the best? And then I was like, oh no, wait, I did actually have a little bit of optimization. Because this was my naive, like, analytical one. And then I had a slightly different one. And I was like, wait, okay, but yeah, no, these are worse. These are just not as good. It's kind of nice comparing these to the optimized versions, actually. Because it looks so bad when you have corners like this. This looks so bad. But as soon as you start optimizing, it's like a breath of fresh air. Neat. Yeah, maybe I'll just max out all the sliders. Except angle, because angle explodes. Angle can only be 0.3. On-screen chat needs to be set to live chat. That doesn't affect the delay. I think it's not, I don't think it's the, yeah, top chat versus live chat is just a filtering thing, right? It doesn't change the delay. I think it's just stream delay. I don't think it's an actual chat delay. Will you set the normals on the border of the bevel, ignoring the tilt towards the center of the bevel, sort of as if there was a support segment outside the bevel? I've considered setting that, yes. I do have support for it in the mesh data. So it's sort of a matter of... I haven't fully decided on how sticky those settings should be, because like I wouldn't want to have a situation where like, let's say you bevel, and then I set my custom property on these half edges to have 0 weight for the normal. But I want to make sure that that doesn't persist in weird ways where like if you delete or add vertices or whatever, I don't want that to like stick around your mesh for too long. And I haven't designed that yet. But it is something I can do, and it is something I want to do because I have the ability to do it. I have the feature, so I just haven't implemented it for the bevel. What about for the even subdivide, create 4 triangles instead of 3 squares? Because I want to avoid triangles. I want to use as few triangles as possible. So that's specifically why I'm filling this with quads. Okay. Wait, where'd my OBS go? There it is. Okay. I like this. I think these settings are pretty good. I think we're in a good spot. Why are we avoiding use of triangles? Because 3D artists use something called edge flow. And that generally involves having quads in your mesh because they have a lot of nice properties when it comes to selection and a bunch of other things that make certain things a little bit easier. So it's mostly a matter of like workflow and stuff like that. I'm not sure what the original geometry was here that would cause this bevel, but but we support it, so that's good. They will avoid the odd subdivide altogether. I don't actually know what people usually prefer, but like some operations like this don't even let you do odd numbers. Like a very common thing is that it would only let you do like powers of 2, so you could like divide it in half or in quarters or in eighths and so forth, right? But I really wanted to have a configurable amount. There are a few things that would make life easier for me if I only let you do even numbers, but I think it's nice to go the extra mile and add some cooler options. Okay. Well, I think we're actually in a good spot to, I guess, implement this soon. It's probably a little bit too late for me to implement this for the actual bevels, because I am up kind of late, and I need to sort of try to fix my sleep schedule. But I am actually so happy with this. This looks so nice. Oh, actually, one last thing. I want to bring back the colors. I miss the colors. We're bringing back the colored area weighted visualization. Okay. Point. Oh wait, these are the internal angles. We're not bringing back the angles. Ignore the angles. We don't like angles. I mean the quads and the, yeah, here, this one. This one. Wait, I feel like this one should just work. Or no, wait, the way that I calculate the area is incorrect. So it's correct here, but the moment I move it here, I love this. So because of the signed area, the area is negative on the backside here. So that's why it's not showing up, because it just gets to invalid colors. Because it's kind of like getting the area from this perspective. Where is the color? That is based off of T, and that's area deviation. Get face area. Wait. This one shouldn't be 2D. Hold on. That's confusing. Oh yeah, the ideal area is different per face now, because the triangles are a bit of an exception. Wait, but then if it's using the mesh data, so it should be the 3D area. Am I manipulating the mesh before drawing it? Yeah, am I like calling recalc mesh when I shouldn't? That's just initialization. And then solve. Then we set them. Oh, I know why. I know why. Okay. Okay, that's dumb. This shouldn't be in here. This is a little bit weird, I think. So then we can bring back the recalc mesh there, I think. Maybe. I should rename this function. This is a really bad name for that function. Okay, now I think it's gonna fix the colors for all the cells. I think, I hope. There we go. There we go. Neat. Oh, jeez. Oh, hold on. Okay, don't explode on me. Oh. Look at those, like, diffraction patterns. It's so nervous. It was like the most nervous anxiety bezier patch I've ever seen. It's not feeling well. I'm so sorry. This is so aesthetic. I love this vibe. I mean, it looks very angry, but... That's not red, but fancy. What color is this? Custom or does it have a name? It's just my own, like, I sort of have my own color palette that I use for everything I do. Any like infographics or videos or and stuff. Can be a product for pattern design. I think it's a little bit too chaotic. And they probably all look pretty similar, so it's probably not varied enough to be used for that. Would make for a neat little, would make for a neat print though. I've been considering like trying to set up some way for people to buy prints from some of my stuff. I just never really know where to do that, what the best options are out there. I feel like I could just play with this all day. It's just so satisfying to look at this goop around. I love this. Look at this bevel, trying its best to fit whatever constraints it's been given. This one doesn't require that many iterations. Oh yeah, the convergence is highly dependent on the number of subdivisions. That's actually good to know. I need way more solver iterations for this when it's highly subdivided. Okay. That is good to know. Cool. Cool, cool, cool. Yeah, where would this point even be here? This is a really cursed, it's a really cursed case. Central weight, I don't know. Let's put it in the center. I feel like those colors should be swapped based on vibes. What would be the vibes? I guess the vibes would be like, I guess the vibes would be, it would be modeling like pressure or something. That's kind of what it's representing. If it's low pressure or high pressure. And so in that sense, I feel like swapping them would make sense because red looks like, that looks more like high pressure and blue looks like low pressure, which would more closely align with those, that heuristic, I guess. Excuse me? Don't explode. Oh, it's nervous again. It's so nervous. Oh, jeez. It's impressive to develop a 3D app in a 3D environment. Smart to figure out all the tricky math here before taking it to a higher level language. I have no plans of taking this to a... Do you mean low level language? I'm not gonna make this in like C++ or Rust or anything like that. I'm gonna stick to C#. But I guess, I mean, I do sort of do low level stuff with shader code. So for like super intensive stuff, I use shader code. And also like Unity's, Unity does have a few tools to like compile C# code to C++ or transpile. So some of the like multi-threading code I also do using their C# to C++ transpilation. So I'm making the whole thing in Unity, and I think it's working pretty well. I think it's gonna be performant enough, because like, I don't know, I showed this last stream. If I just like shove a bunch of primitives in here, like this is gonna be a lot of triangles here, a lot of vertices, a lot to think about. Oops, I failed at clicking. Clicking is hard. Like, I don't know, selecting all of this, you might think that would be expensive, but if you just do that on the GPU, it is not expensive at all, and it is basically real time. So, it is no problem. Yeah, so I'm good in my C# ball pit. And an editor, does that matter here? I mean, running it in the Unity editor will generally always be slower, so it's only going to be faster in a build. So it matters in the sense that like the performance I'm seeing here is not going to be entirely representative. But it goes in the positive direction in that if it goes in some direction, it's going to be more optimized in a build rather than in editor. Are the selections optimized, or is it just pure brute force on the GPU? It is brute forced on the GPU, and it is completely fine so far. So I have done 0 optimizations beyond brute forcing it, because GPUs are fast, actually. If you just make use of all the cores in the GPU, you can just like blaze through everything. I just hit my finger. But it kind of makes sense. Like if you consider the number of pixels on your monitor, there's a lot of pixels on your monitor, and every frame a video game renders, it's going to compute a bunch of math for every single pixel. And so it's kind of similar to mesh elements here, right? Like how many vertices do I have in this scene, and how much math do I need per vertex in order to calculate whether that vertex is inside of my selection or not. Like compare that to the amount of math a single fragment shader does for like some physically based shader or whatever. Like it really isn't that much computation for the GPU to do something like this. So GPUs are fast, you just gotta make use of them. And so they're just sitting there, just ready to be used. Yeah, so I'm pretty happy with this. This is working super well. I still do most of the mesh operations I do on the CPU though. Can I show? Okay, can I maybe? Yeah, I think that there might be some mesh operations that are slow because I do some naive recalculation of the mesh. So like if I extrude here, Okay, well, that's also fast. Okay, I thought this would be slow, but it is not slow. It's certainly slower. I can tell that it's dropping frame rate a little bit. But I guess it worked fine. Now, so when I do any change on the mesh, literally any change at all, it recomputes everything. Like the entire mesh recomputes their normals. Like very, like brute force recalculate everything for any tiny amount of change. I don't do any like selective updating at all. So I thought this would lag because I have so much geometry here. And because I do the mesh recalculation on the CPU. But that's multi-threaded on the CPU, so I guess that's why it's working out regardless. Lots of room for improvements, yeah. Look at this bevel. Wait, can I call it a bevel? I don't know if it counts as a bevel. Some kind of sheep. Oh, I didn't fix the scale handle. Oh, I don't have planar scale. Ugh, it's over. Literally unplayable. What a shitty piece of software. Well. Would it even be possible to calculate the mesh operations on the GPU? It would require restructuring the node first on the CPU and then setting them off, right? I mean, would it be possible? Yes, absolutely. Yeah, totally. There's nothing stopping you from doing something like that. The biggest thing with the GPU is it's just a matter of, can you parallelize your algorithm, right? So for example, when it comes to selection, like if I want to select a bunch of vertices, do I need to check every vertex one after the other, or can I check each vertex independently? In this case, I can check them independently, which means that the GPU is going to be really good at distributing that task across a bunch of different cores. But if you want to do something like a kind of like the mesh optimization thing we did with a goopy triangle. Like, each step along that iteration needs to know the results of the previous step. And so there's a dependency chain. So there you actually have to do one thing before the other. And so those things are generally harder to parallelize, because then you have to synchronize all of your threads at every one of those points. I could, although for that unfolding thing in particular, I can parallelize the individual applying of forces and calculating of forces, but I still need to do it in order down the line. But even that I can do on the GPU as well. It's just like, it's a matter of dispatching the same compute shader like multiple times in a row, and then just making sure that I have synchronization points between each dispatch. Or just setting up like dependencies that like there's a dependency on the previous thing to finish. Okay, I should really go to bed. So, are there any last questions or thoughts before I head off? I feel like I kind of ruined this shape. I just kind of wonked it up. It's a weird shape now. Maybe I can unwonk it a little bit. Well, now it's just going to be slightly like a corner, but not quite, which is probably worse than being like intentionally very off. What are you using to talk to the GPU? I mean, it's not CUDA, but I don't know what Unity uses internally. So like what it looks like from my end is that I dispatch compute shaders, and those compute shaders are written in HLSL. But Unity probably cross-compiles that to whatever rendering backend I'm compiling to. So like, I can make a Unity build for DirectX 11 or DirectX 12, but I can also make a Unity build for Vulkan or OpenGL or for iOS Metal. So like, I think Unity handles the per platform differences there. Well, ideally, not always in practice, but yeah, so from my end, it's mostly like I write my compute shader in HLSL, and Unity deals with the platform differences, and then dispatching and synchronization, all of that should work. Although I tried to take Half Edge to an indie game dev conference in Spain, in Malaga, and I was like, well, I mean, it's working fine on Windows, so it should work fine on my laptop as well, my MacBook. And my selection didn't work because that was compute shader based, and somehow, somewhere, something was different between like DirectX and Metal. Ugh. I think there are some quirks in like when it comes to like buffers on the GPU. I think they deal with either it was like if you allocate a buffer of memory on the GPU, I think it's like some rendering platforms fill it with 0, but some rendering platforms don't initialize it to anything. It just leaves it as whatever it used to, or whatever memory was already there. It was either that, or it was... Oh, I think it's actually that like DirectX, I think, is lenient if you try to read buffers out of bounds, but I don't think Metal allows you to do that. That they will actually like, I don't know how they handle it, but I think on DirectX they let you read out of bounds, and it resolves in a way that worked in my use case, but I'm guessing that just didn't work on Metal. So yeah. I am making a modeling tool in Unity, but not for Unity. So yeah, it's a 3D modeling tool. Kind of like Blender, except it's not Blender. Studying computer graphics and it doesn't even work on most people's integrated graphics cards? Oh no. Okay, will there be cats next stream? That is up to the cats. Well, there's cats above me over here, but they're kind of off screen. How do you track your milestones to-dos? I use Obsidian for my notes, so I usually just put to-do stuff in there. Some of those notes are public, so if you check below the stream, there's like a description there. There's a link to the website for Half Edge, and there's an FAQ. There's a feature list, things I'm gonna do for 1.0, things I'm not gonna do for 1.0, and so if you're like curious about exactly what's gonna go into Half Edge, you can check out that list. Are you going to be selling it? Yes, it's going to be a commercial piece of software. I haven't decided yet on price or platform. I'm probably going to do a one-time payment. I don't know the range. It depends on the feature set at release. But definitely not less than $100. So it's going to be more than $100. And less than $1,000. That's the very wide range. Yeah, so a one-time payment, probably somewhere within that wide range. I don't know yet exactly how expensive it's going to be. I have considered releasing it through Steam, but I'm not 100% sure yet. It would be a really interesting experiment to release it on Steam, but it kind of stings to have Valve take 30% of everything on Steam. So I don't know if I should put it on itch, but if it's on itch, I get no, like, I don't get any like marketing on itch, I think, or I don't actually know how much tools, I don't know how much marketing tools get actually, either on, well, on either itch or Steam. Kind of an unknown. $100 for doing 3D objects one could do in Blender? You kidding? No, I'm not kidding. You are very welcome to use Blender. I'm not gonna stop you from doing that. You're welcome to use Blender. I wouldn't recommend Steam at the beginning due to the reviews when there are still many things to polish. I mean, that's mostly a matter of making sure that it's well tested before releasing. So that's less to do with the platform, I feel like. And I will have testers before the 1.0 release. I have a private test that's invite only right now, and then hopefully that's going to be this year, but that's super optimistic, but maybe early next year. And then depending on how that goes, and depending on the scope and the pace at which I can get things to 1.0 state, yeah, we'll see how it goes. 100 is cheap compared to other modeling apps? Yes. This year is in 2025. Wait, is it 2025? Yes. So that was a very optimistic milestone that I wanted to have like a private alpha test, but what features do you have or have planned to cater to level designers specifically? So it's not subscription based, right? No. I mean, it probably should be if I want to make money, but I just really don't like subscription models, and I'm kind of doing this just because I miss Maya, and I don't want to like pull the same bullshit that Autodesk does. I mean, I would never go that far to be that bullshitty, but okay, so like level design stuff. Right now there's not that many things like that, but it could be a bunch of different things. So for example, like a very simple thing is this grid, right? There's a grid, you can place stuff on it, and if you want to modify the grid, I have hotkeys to double and halve the subdivision of this grid. Like, this is something you tend to use a lot in level editing. Just having a grid that's like always present, and you can like quickly subdivide it and work with it, like that kind of stuff. That's something that like, it's a very simple feature to have a hotkey for grid size, but it makes a huge difference if you do a lot of like axis aligned stuff that you tend to do when you're making like walls and ceilings and floors, right? So that kind of stuff. That's just one example. What else? I guess there's not that many things in practice right now. Hold on, cats are happening. Salad. Hey. Mr. Shenanigans. Mr. Shenanigans. Mr. Shenanigans. Yeah, you're full of shenanigans. What? You don't want to be here, I know. But I want you to be in my lap. But you don't want to be in my lap. Ow, 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 ow. Hey. What if you integrated code into Half-Edge so people can not only 3D model but also make their games in it, maybe using C# for it? Oh, I'm not going to make a game engine. And, in fact, that is against Unity's TOS. So, I'm not going to do that for multiple reasons. I will, however, I will have plugin support, which is sort of like modding support. So you're going to be able to like write plugins for it. God damn it, salad. Oh my god. What does the TOS say? You're not allowed to make a game engine in Unity, according to their TOS. Scripting support is amazing, but you know that people who make games in it, C# reflection. I mean, but that doesn't make it a game engine. Like, you can already do this in any Unity game as well, right? So that's not against TOS. Level design tends to have other things than just meshes, like collision checks, loading and unloading zones. How could Half-Edge integrate with that? I have considered having some kind of support for like collision meshes. The only stuff that's tricky about those things is like, it tends to be very engine dependent. So like, I don't know if any of you have used Hammer before, but Hammer used to have these like utility textures. So you would have a texture that's like, this is a texture that's the trigger texture. And then in your editor, you could hook up logic to your, anything you texture with the trigger texture, right? Similar with like, you could make like invisible walls in your modeling tools just by applying like a texture that just is the texture for invisible walls. So that kind of workflow is really nice, but so much of that is like engine dependent. So I'm not entirely sure yet. Like if you have, I don't know, for custom engines, you can probably retrofit it to do that regardless. But for like, if I want to make this work for, you know, Unity, Unreal, and Godot, I don't know what their collision import pipeline looks like. And like, I suppose for Unity, I could make a plugin that imports, you know, half-edge meshes with all the proper like properties. But yeah, I'm not sure yet. I'm not entirely sure how that's gonna shake out. I'm not sure how like object behavior is tied to their textures. It's very hacky, yeah, for sure. But it's also incredibly convenient. But I mean, I could like wrap it in a way where it's not literally applying a texture. It's more so like you tag a mesh with a certain feature and then it's going to change the way it looks. Yeah, custom importers and whatnot will kind of solve that. Can you have arbitrary grid rotations? Eventually, yes. Right now there's, right now I just have like preset planes for like, you know, XY plane, YZ plane, and ZX plane. But yeah, I actually did add support for custom rotations for the grid, but I don't know if I have a way to get those right now. No. Okay, I think, well, I have support for it in the backend. I've just never, I just haven't re-implemented it. Will there be Boolean operations? I'm not sure. If there will be, it's going to be very limited. Like a prism intersection type of thing where like, okay, so here's the thing with Booleans. Solving Booleans for stuff like this is a nightmare. Booleans is a very, very tricky problem to solve, especially if you want it to be performant and if you want the topology to look good. It's a nightmare. This sucks. But if we can kind of restrict the types of Booleans that I allow, like doing a Boolean like, I don't know, kind of like this, where you have like a cylinder and you want to punch through two flat surfaces, making a Boolean for this is easy. And I feel like the majority of like valid Boolean use cases kind of look more like this than this, right? And so I'm considering trying to solve like a simpler subset of Booleans to kind of just do this, like using a shape to cut a plane, like flat surfaces like this, or maybe like cubes, cutting into cubes, like this type of Boolean operation. These operations are relatively simple, and these I could probably implement without any issues. What makes a spherical Boolean problem that much more difficult? Because Boolean operations are kind of full of literal edge cases and literal corner cases that involve a lot of like weird intersection tests, equality tests you have to do. You have to check if they're like coplanar, and if they're not quite aligned, like you need to like decide whether you should consider them to be aligned or not aligned. Like there's a bunch of weird caveats there, and it's kind of rough. It's tricky. How could you properly communicate to the user which objects are eligible for Booleans? I don't know. I can probably figure something out. I mean, some things that I already have is like the actions I have in the sidebar. Some of them only light up if you meet certain requirements. So like, you can see that some of these buttons are not available unless I select something, right? So a lot of these things are kind of conditional. So I select two edges and then this one becomes available. So I could do something like that where like the button is literally just not available, and then maybe a tooltip that tells you why. Yeah, there's different ways of doing it. I could maybe do something like, you know, Booleans maybe work by selecting the faces involved if it's like a subtraction, and then I check if the faces are planar and then I allow it. I don't know. There's various different ways of doing it. Or I just make it not work. Like you press the button and nothing happens, and you're just gonna have to be like, oh, okay, I guess something about this setup doesn't work. Which I think is not the best design, but a lot of software is designed like that. So, and I think people generally don't have very high expectations on Booleans anyway, because they're usually not very stable. Oh, I can't really show that, but another thing that like level editing tools tend to have, the 3D modeling tools don't have, is like texture alignment tools. If you have like a wall with a texture and you want to align the texture to the bottom of the wall, like usually in a 3D modeling tool, you would have to open the UV editor to do that kind of thing. But in Hammer, for example, there would be like hotkeys and shortcuts to just like tell this face to align the texture to the bottom of the texture. And that would like automatically move the UVs of that face without ever having to open the UV editor. And also things like if you want to like stitch the UVs across this face, kind of like take the boundary of this and just take the UVs of this and stitch it to this inner edge here. Like that kind of stuff of like take the UVs here, stitch them here, unfold this part, and then you would make the wall just continue along this thing. And in Hammer, that would be, you basically select a face, and then I think it was like Alt right click, and then immediately this face gets UV mapped to be stitched together with this edge, like perfectly seamlessly. You can also do that in Blender in the 3D view without opening the UV editor. That's cool. But yeah, that kind of stuff is stuff like not all 3D editors have that kind of thing. I didn't know Blender had that though. What's the shortcut or workflow for Blender? Because I imagine it's not Alt right click in Blender. Okay. U? Wait, you just press U and then it magically fixes itself? Or like what's the selection? Or like how do you... What does it do, like, with your selection? Because with Hammer, it's kind of like a multi-step process, right? Pop-up menu with options? Okay. Right, oh, for the alignment stuff. That sounds similar to Hammer, because Hammer also had this, like, alignment window. But yeah. Blender has add-ons for everything. That's true. There are a lot of add-ons in Blender. Would you have a way to automatically scale the texture while wrapping it around a loop of faces so it doesn't show a seam for repeating textures? I could do something like that. I mean, it's like the sky's the limit. I can do whatever I want. And UV tools is actually the thing I'm looking forward to the most. So if you have like ideas of UV things you would want to see, I would love to just go down the list and implement all of them. So, because I like UVs. They're exciting to me for some reason. But first I need a UV editor. So I don't have that yet. I'm currently focusing on the 3D editing stuff. UV editor, probably not gonna have a UV editor for 1.0. Or no, sorry, for the closed alpha, I'm not gonna have a UV editor. But for 1.0, I'm gonna have a UV editor. That's for sure. Your room looks so cozy. Thank you. I really like my room. I painted the walls myself. And here's some trivia. Speaking of level design or Hammer, the color that I chose for the wall, it's the Team Fortress 2 red color. I specifically grabbed the color palette from Team Fortress 2, and I was like, convert from RGB to whatever paint uses, and then I ordered custom paint with that color, and it worked really well. It looks great. It is a little bit tricky when it comes to like cameras and filming because it's so overwhelmingly red that like you kind of need to like shift the tones in like slightly towards red, otherwise I look green against the red background. But I think it looks nice. Yeah, I do have a bias towards red color, so a lot of my like hardware is red. What's wrong with the octagonal prism selection visualization? Oh, that's just a bug. So the way that I do the hover previews right now is just very stupid. And so basically I draw a quad for every face you have selected, I think including triangles. So I just draw a quad. Whatever you select, I draw a quad for that face, including if it's like an octagon. So I'm kind of running out of vertices in the quad. So, yeah, that's just because it was like a quick and easy way to do it, and then I just haven't looked at it since then. Played a lot with Conal Elliott's functional image composition stuff, and it's exciting and fun. Makes me wish 3D shapes were described as functional volumes. I mean, there are some editors that work with like implicit surfaces and sign distance fields. Usually the problem with those is that you don't get explicit control over like texture mapping and UVs. So they're really good for like organic procedural shapes. But yeah, it's kind of a different type of editing. But yeah, sign distance fields are like the perfect way to do booleans, because then booleans are super easy. The whole problem with booleans is because we're doing it on polygonal geometry. I did consider having sign distance field primitives as well, as like a separate thing, like on top of having polygonal meshes. But I'm not sure yet. That kind of gets into the like non-destructive workflow thing, which I haven't decided yet on whether I should go down that route this early. Probably not. Not 3D editor or game dev. What's UV? UV mapping is when you have a 3D object and then you want to put a texture on that object. You basically need to unwrap it. You need to flatten the whole object into a flat plane. Kind of like if you have like a wrapper around, you know, a box or something. You kind of need to make sure that you have the texture should be mapped to the 3D geometry in a specific way. And that act of unwrapping objects, that is something you do in a UV editor. So UVs is just a name we use for those 2D coordinates that refer to this 2D space. Gaussian splats are kind of like that now. Would Booleans be hard on splats? I don't know entirely how Gaussian splats work. I haven't used them myself. I haven't read much about them, so that seems to be more like a photogrammetry type of thing. How would Booleans work on those? I don't know enough about Gaussian splats to know whether Booleans would be easy or not there. But if it's sort of like a point cloud, I mean, if you want a Boolean, a point cloud with a primitive shape, that's pretty easy. If you want a Boolean, a point cloud with another point cloud, I'm not sure how that works. So, okay. Do you plan to do super advanced UV things? Yes. I'm not sure what that means, but yes, I would love to do that. Have you seen the video, heard about surface stable pixel dithering? I haven't seen the video, but I know of it. I think I looked at it a little bit when it came out. But yeah, seems nice. Are Gaussian splats even solids or just surfaces? I thought, okay, I'm gonna make a huge guess now because I actually haven't looked into this, but I think, isn't Gaussian splats basically a point cloud where every point has like a probability function or something like that? And then maybe some data for like color. Or am I completely off? Gaussian referring to that probability curve? Little lights in space. I guess there's light fields as well. I don't know how those work. Maybe those are just like 3D textures. What about straightening edge loops in UV and proportionally transforming the UV mesh attached to it? Yep, that stuff. I would love to do that code. What about expressions, parametric design? Yeah, I haven't decided yet on procedural stuff or non-destructive workflows. So parametric stuff is going to take a backseat. I want to get the manual workflow working well first. Once I have that working, then I can start thinking about the rest. But I want the act of manually creating your stuff should be fun and good and fluent, and it should feel like you're one with your creation, rather than fighting multiple windows and all of that garbage you sometimes have to wade through. Okay, I should really go to bed. It is late, and I need to eat something before I head off as well. Head off? It sounds like I'm going somewhere. I have a very important meeting. But no, I'm just gonna go to bed. but I need to eat something before I go to bed. Alright, any last questions? Small questions? No big questions? Just want to say I love your work. Thank you, Raphael. Thank you. Less than 1 hour? Wait, what's less than 1 hour? Okay. Bed is a really important business partner, yeah. What's the current state of Half Edge? It's in a state of awesome. Yeah, that's right. It's like pre-alpha right now. I mean, there's a ton of bugs still. There's stability stuff that I don't have. I don't have multi-object support. There's only one object in the scene right now. I'm missing certain like export features. Like I can't export to GLTF or import GLTF. So like a lot of the basics are there, but there's like stability fixes I need to do. But anyway, I wanted to link Half Edge's website. If you're interested in Half Edge or you have questions about it, a lot of it is answered on the website. There's also a Discord server if you want to lurk, or if you want to like get notifications when there's a stream, or if you want to know when any potential future alpha or beta is going to go live. That's just a place for news on that. Is there anything else I want to talk about before I head off? I don't think I will stream tomorrow, because tomorrow I'm going to have a lot of stuff. Unless I stream like really early rather than late. But I think, yeah, I think that's it. Thank you all for joining. Thanks for hanging out and for enabling me to continue doing this very risky project that that might not be financially viable in the end, but hopefully. Yeah. Oh wait, just need to make sure I got all the stuff closed. There we go. Save. Okay. I also don't know. I'm actually not sure like how YouTube handles closing the stream. If it's like gonna take stream delay into account or not. I don't know. Okay, I'm gonna do a countdown. I'm gonna do like 3, 2, 1, and then I click end stream. And I'm kind of curious if the stream is gonna end when I do that, or if it's gonna end earlier than that. In which case, like my sentence right now would probably get cut off at some point. But we will see. Leave a comment, etc. But yeah, alright, bye everyone. I'm gonna end the stream. 3, 2, 1. Oh wait, I got a pop-up, sorry, wait. Your stream will stop immediately, you will no longer be live. Yes, that's the point, okay. Okay, I'm gonna try this. 3, 2, 1.